By the question C, we are supposed to calculate the speed of the particle when it reaches the bottom plate. Well, the particle here experiencing a force will be accelerated down, and the force pulling it down, causing the acceleration, will increase therefore the speed or the velocity. Now, what do we know actually? First, what we know is that the initial velocity is 0 meter per second, which is given by the word is placed near the top plate, and it implies that the particle is at rest. So now the speed of the particle as it reaches down is what we are looking for. Now, we know that the final velocity or final speed of an object is equals to the initial speed plus accelerations, in this case all in y directions, times the time needed. Now the problem is, we know already the AY calculated in problem B. We know that the initial speed is 0. But the delta t is not yet known. And that is exactly what we need to find. Now, if we want to find delta t, we can go back to one of the physics formulas in distance. In this case, the distance is the d. So distance in y directions, which is the distance between the two plates, is the initial speed times delta t plus 1/2 a delta t squared. So this one is 0. I can have delta t then. The delta t squared equals with the distance between the two plates divided by 1/2 accelerations. 1/2 accelerations. Now, it can be shifted for the 1/2. The 2 goes up, can be 2 times d divided by ay. Now, it is a challenge for you to combine both of them into one single formula. You may pause yourself this video, half a minute, 1 minute or 2, try to combine the formula and create your own new formula. Now you may do it. Alright, now I am not going to show you how to do the two combinations of v velocity final, velocity initials ay plus delta t with this delta t squared. But what I can do now, after combining them, then you will get 2 times a times the distance, the a is the a in y directions, will be equals with the final velocity, final speed in y direction squared minus initial speed in y direction squared. Now, we just need to calculate the final speed then. So the final speed, v final in y directions, is square root of 2 times ay times d. Now we know ay, which is in the second question, 2.38 times 10 to 26. (2.38 times 10 to 26 meter per second squared). Multiply with 12 times 10 to minus 3 meter. So you will get meter squared and over second squared, which then under the square root will give you meter per second. Now, we combine first 2.38 times 12, and the 10 powers will be 10 to 23. I'm going to calculate 2.38 times 12, 28.56. But then I need to square root. Maybe I need to multiply it by 10. 16.899. 16.899. So let me repeat again. What I just have done is that I multiplied 2.38 with 12 with 1, 10 to 1, and then 10 to, this is 23, 22 under the square root. So now these things has been 16.899, and 10 to 22, square root of it is 10 to 11 meter per second. All right, that's all. That's the answer of our questions today for the speed of the particle. In scientific notations, the final speed is written as 1.69 times 10 to 12 meter per second, and this is 3 significant figures.